This topic focuses on introduction to complex numbers, being able to simplify them, add and subtract them, and multiply. So this is the definition, the form of that complex number. We did talk about the last video, a longer definition of the complex number system. This is your real part. And then the plus bi is your imaginary part. Remember, I represents the square root of -1. So what we want to do is we want to simplify some of these examples into standard form of a complex number. So example A, 2 plus the square root of -9. So talk about that negative first. Replace it with I out in front, and then the square root of 9 is 3. So that becomes a 3. Now we have the real part. This is my real, and that's my imaginary. Just going to erase that, you don't need it, but now it's in standard form. Second example, we have a negative underneath this radical, so that becomes an I. Square root of 25 is 5, so you have 5i. In this part, if you wanted to write it like this, you could go 0 plus 5i. This is your real piece, and this is your imaginary. More students, I would say, would just rewrite it as 5i. It's probably easier. Next is -6i, and then we have plus 3i squared. If you remember from earlier, I squared is the same thing as -1. So you have -6i plus 3, replace that I squared with a -1. Now multiply 3 times -1 is -3, and then put it in standard form. So we have your real part first, then your imaginary. So I'm just flip-flopping those terms. Last example, -6i cubed. That's the same thing as I squared and I multiplied together, plus I squared. Remember, I squared can be replaced with -1. So I'm going to replace this with -1. I'm going to replace this with -1. And then I still have -6 and I. Now, -6 times -1 is +6. I plus -1. Put it in standard form, so the real part first, then the imaginary. So we're flip-flopping those terms. Let's go on to adding and subtracting. When you add and subtract complex numbers, you want to combine like parts together. So you're going to combine the real parts together and then the imaginaries. So imagine this is one complex number adding to another complex number. So I have 4 plus 5i. I'm just dropping these parentheses now. Plus 2 minus 3i. Here are the like parts, the real and the real. So 4 plus 2 is 6. And then you have your imaginary. 5i minus 3i becomes 2i. That is now in standard form. Second example. You have a complex number and a complex number. But notice what's out in front of this complex number. It's a -4. So it's like you have to distribute that 4 through. So I'm going to leave this first complex number alone, 3 plus 2i. And then the second complex number and distribute 4. So -4 times 1 is -4. And then -4 times -5i is +20i. Now I'm going to go ahead and combine like parts together. So I'm going to drop the parentheses, 3 plus 2i. And then I have -4 plus 20i. Combine the like parts. So real part, 3 minus 4 is -1. imaginary, imaginary. 2i plus 20i is 22i. So there's your new complex number in standard form. We've covered adding and subtracting and simplifying. Now let's go on to multiplying. So we're taking a complex number times another complex number. Think of this as FOIL. First, outside, inside, last. So I'm going to multiply 4 times 2, which is 8. That's first. Outside, 4 times negative 3i is negative 12i. Then we'll go to inside. 5i times 2 is 10i. And then last, 5i times negative 3i is negative 15i squared. So we've now FOILed it. Now we need to simplify it. So I'm going to take care of this I squared first. Remember, I squared is replaced with a negative 1. And then negative 15 times negative 1 is positive 15. I have like terms here with a negative 12i plus 10i. Those become negative 2i. And then we have this 8 out in front. Again, we have like terms with these two. 8 and 15 combined together to give us 23. And then we have this minus 2i still left, minus 2i. Last part is finding the real numbers of a and b such that make this equation true. So we want to find out what would a equal. And this is an equation. So a has to equal its imaginary part. So in this case, a equals negative 10. Then bi must equal the bi over on the other side. So set bi equal to 6i. And we solve this equation for b. So I'm going to divide both sides by an I. And what that does is it cancels out an I and I, and an I and an I. So we're left with b equaling 6. So what makes a and b true? A is going to equal negative 10, and b will equal 6. Second example, a plus 6 plus 2bi. So I have my real part, has to equal my real part. So a plus 6 equals 6. And then I have my imaginary part equals my imaginary part. 2bi equals negative 5i. And I solve each of those equations for their variable. So the blue equation, I want to solve it for a. So I'm going to subtract 6 from both sides. And I get a equals 0. Over here, I'm going to divide both sides by 2i. And the 2's cancel, the i's cancel, the i's cancel. So b equals negative 5 halves.